Okay, hello everyone. We are the team Caffeine Coders. Today we would like to demonstrate the skeletal increment of our trivial compute system. So first, I would like to introduce our teammates. Casey, who is a lead architect and a lead CM engineer. Kelvin, the lead tester and the programmer. Justin, the project manager and the lead SQA engineer. And Ting-Wei Wang, the lead programmer and the lead presenter. So first is about the subsystem, which is majorly composed of the cloud service server and the graph user interface. This diagram shows the trivial compute system architecture. It used a client-server model with a cloud service. The Express server handles REST endpoints and serves the application. The client side uses HTML, CSS, and JavaScript for the interface, while the backend includes a cloud service and game logic. Cloud service Google Firebase manages game data, user info authentication, and serverless operations. Game logic manages game states, player turns, question answered, checking, and scores. The interface uses HTML, CSS, and JavaScript for interactivity, communicating with the server and updating the display. So here is our Firebase of our project, which majorly contains the authentication function and the Firestore database function. And for the backend, which is majorly in the app.js file. And the other backend is contained in the src folder, which is the Firebase function and the game logic functions. And for the executable graph user interface, which basically contains the HTML, the CSS, and the JavaScript file displayed here. And so for the messaging between subsystems, the server uses a REST API with standard HTTP request for communication between web pages, and the server returns the modular JavaScript for organized operation. The database interface through the Firebase SDK, standardizing operation like creating, reading, updating, and deleting data, with additional support for directing HTTP requests to the Firebase API. The GUI uses HTML for structured web page, CSS for styling and responsive design, and JavaScript for client-side logic and interaction, sending HTTP requests to the server's REST endpoints. So for demonstration, we could start our node app.js file. Then the server starts to run. So we could see that so we could use the authentication function for demonstrations. So in our authentication, we have provide this user and password. So so if we look at here, we can see that it has a successful login. And we can see here that we are from our database that there is some usage here, and also some usage for our authentication, which demonstrate the system is connected. So for the final executable graph user interface, we follow our design in the software system requirement. That here I'll go through a quick demonstration. Well, so here's the manage questions page and the manage categories page, and finally to start playing games, we could add here. So this is our demonstration of our cycle increment.